Going to do these center of mass problems for you now, starting with number 1. This is in Chapter 9, or AP Physics. We have in this one, how many particles we have here? I have a 2 kilogram particle that has coordinates negative 1.2, comma 0.5, and that's in meters. And I got another one, a 4 kilogram particle that has coordinates 0.6 and negative 0.75 meters. Just the two. They're lying on a horizontal plane. Of course they are. At what x and y coordinates must you place a 3 kilogram particle such that the center of mass of this 3 particle system has coordinates negative 5, negative 0.5, negative 0.7. That's kind of, I don't know. Why would you make the first problem, the very first one, one like this? I don't know. So in the center of mass, oops, sorry, I bumped my head on the frame there. Center of mass is at, we want it to be at negative 0.5, comma, negative 0.7. If I were making these, I think from like a pedagogical point of view, the very first problem should just be like use the formulas. But they're making this one like, so those are the 3, and it's got to add up to this. So, okay, fine. So that x coordinate of the center of mass, I'm thinking back to my notes here, to this, right? We just have to do this. It's just that we know this, and we're missing like a piece of information here. So, okay, fine. We can still set that up. So the x coordinate of the center of mass is negative 0.5. And where did that come from? Well, that has to come from taking the x coordinate of the first one and multiplying by mass, plus the x coordinate of the second one, multiplying by mass, and the x coordinate of the third one, which we don't know, and multiplying that by mass, and then dividing by the total mass. And then algebra. So let's see, negative 4.5 is equal to, that's negative 2.4. Ooh, is that positive 2.4? That's going to be a big old 0 there, isn't it? 3x, so x coordinate of the center of mass. Oh no, sorry, x. We know the x coordinate of the center of mass. The x coordinate of this third particle has to be equal to negative 1.5 meters. Okay, that was the x direction, and then in the y direction, we want the center of mass to be at negative 0.7. So y coordinates 0.5 times 2 plus negative 0.75 times 4 plus I don't know what times 3. You know what the French say when they're doing a problem like this? That's the je ne sais quoi. Alright, so multiply that over here, negative 6.3. And then what do I got here? I have a 1 and 3/4 of 4 is 3, so 1 minus 3 minus 2. I hope I'm doing this right. A little bit of cowboy math here, the Wild West. I think I'm okay. Let's find out. So negative 4.3 is equal to 3y, so y is going to be equal to, what, about 1.4-ish? Let's just check that real quick. Well, let's do this math real quick. See how. What? Oh. Okay, that's good to 2 decimal places. What does the book say? That's not the right thing. There we go. Negative 1.5 and negative 1 point. Did I lose a negative sign? I did, yeah, negative. So that's good. Great. That's how you do it. So just a little weird in this one that the unknown was one of the locations of the points. So we're big kids, we can handle that. Figure 2, here we go. Just finding the center of mass. Okay, so we have the scaling. Okay, so this little graph, they give us the scaling. It's just scaled by 1, so everything is what it looks like. So I have mass 1 is, just write down this info. Mass 1 is 3 kilograms at 0, 0. These are all in meters. Mass 2 is 4 kilograms at 2, 1. And 8 kilograms at 1, 2. And they want to know the x and the y coordinate of the center of mass, and then some other part C, which we'll deal with in a minute. So A, what is the x coordinate of the center of mass? The x coordinate of the center of mass is found by taking the x coordinates, multiplying by the respective masses. There's a weighted average, literally, or a massed average, I guess. They're not weights, they're masses, but you know what I mean. Okay, so let's see what we have here. 16 over 15. So 1 and change. So the x-coordinate's at 1.07. The y-coordinate of the center of mass is y-coordinate times mass, y-coordinate times mass, y-coordinate times mass. And that's, let's see, 4 plus 16, 20 over 15, isn't that 1.33? Pretty sure. And then in part C, they want to know if M3 is gradually increased, does the center of mass of the system shift toward or away from that particle, or does it remain stationary? Well, if you increase the mass of any particle, if you think about taking that to the extreme, if the mass is increased so much that that particle just completely dominates the total mass, of course that's going to make its coordinates, let's say we're increasing this one that's already pretty big here, as you increase these things, it's going to make that 8 become more and more and more part of course that would be added in here too. If you think about if you made this like a million, then you have a million times 1 plus, like, if you think about it like in terms of limits, a million times 1 plus some tiny things that we don't really care about, over a million plus the tiny things that we don't really care about, those extra masses. So it's basically just going to give you, like, those are going to cancel, and it's going to get closer and closer to those. So we'll just say closer to M3 if you increase its mass. We skipped 3, you can do 4. This isn't hard, right? Okay, this is kind of similar to the example that I gave you in the notes. We got a little frame type thing. It's only got 3 sides, and they told us, I've had students in the past, they put these like really faint axes in, but they did actually say where the x and y axis are. So this is your origin right there. Just in case you didn't notice those. The 3 uniform thin rods. The uniform just means that they're not lumpy like that. In other words, the center of this one is here. The centers are actually in the centers. In inverted U, the vertical rods each have a mass of 14 grams. And this one has a mass of 42 grams. What are the x and the y coordinate of the... Oh, and the length of each one is 22. And there, it's like square-like. All right. If you're thinking, oh, I got to change these to kilograms and this to meters, you don't have to. You just have to be consistent. So let's do... Does this have an a and a b? Yeah, x and y coordinates. So a, the x coordinate of the center of mass is, hold on a second, I'm not going to do anything here because this thing actually has symmetry with respect to this line right here. So the x coordinate is at 11 centimeters, if that's the origin, right? Half of that. You can set up the math if you want. Maybe you already did and you're checking it now. But I can just see here by inspection that that has that axis of symmetry, so I don't need to do that. This one I am going to need to do. I have y coordinate for this piece is going to be at negative 11 times its mass plus the y coordinate of this is 0 plus times its mass. Did I say plus there? Sorry if I did. Plus the y coordinate of this piece times that's not the mass of that. Sorry. Divided by the total mass is, do I have those right? Is it 14 and 42? It is. So 14 and 14 is 28 and 42 is 70. So it looks like I got 2 of those. So I got negative 11, turn on calculator first, negative 11 each. And just before I hit enter on this, what we should expect is some negative y coordinate. Because this one is more massive, it's going to be somewhere in here, right? It's going to be closer to this than halfway. So it should be less than negative 11, or greater than negative 11, I mean, right? Absolute value less than. So in between 0 and negative 11 is what I'm trying to say. So enter negative 4.4, we got centimeters. And I used those units, and everything came out fine, and I just get the same units that I put in. So let me just do a quick check, make sure that we're good there. I feel pretty confident about that. I was like, oh, that's an even numbered problem. Just kidding. I do have the even answers somewhere, but not in front of me. But I feel good about that. Okay, so number 5, last one. What are the x and the y coordinate of the center of mass of the uniform plate shown in figure 938 if L is 5 centimeters? All right, I'm going to go ahead and make a little sketch of this. So let's see. Let me put some grid marks on here. I think that would be helpful. If I had a piece of graph paper, that would be even better here. So this piece over here is 2 by 3, as you can see there. And then there's this skinny piece up here, which is 1 by 4. And then there's this 4 by 2. I guess these aren't different pieces. They just are laid out on this axis. I shouldn't be calling them separate pieces. It's 2, and then 2 by 2 here. Okay. So this is different than these little rods that I had here. But each one of these, like for example, you could just cut this into 4 pieces as they lay out in the quadrants here, but I think we could probably do it a little bit more efficiently than that. But what I do need to do is I need to cut it into pieces that have a nice symmetry that will make it easy for me to locate where the center is. Now there are lots of ways of doing that. You could do it by quadrant, and then the center of this one is here, 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 just like right in the middle, and that would be fine. I think I'm going to do it like this. I'm going to do this piece, this piece, and this piece. So I'm going to cut it into these 3 rectangles, because each one of those rectangles, well, is a rectangle, so it has X and Y symmetry, and it's very easy to locate the center. So this is this is 6 long, so the center of it is halfway through there, 3, and it's 1 high, so the center is halfway there. So all we need to do is just make sure we understand what where that location is. So it's at 1, 1, 2 and a half. It's at 1, 2 and a half. It's just in the middle of this rectangle. And here, this is at -1, 0. And here, that center is at 0, -3. Lots of other ways you can chop this up. If you committed to some other way of chopping it up, then you should try to follow through that way and see if you get the same answer as me. Now the other thing, maybe the most tricky thing about this one, is they don't tell us what the mass is. They just say that it's a uniform plate. So what are you supposed to do with that? Well, if you look at, if this is on a piece of graph paper, if it's uniform, then like how many boxes worth of graph it takes up, that's a perfectly legit stand-in for the mass. The mass is, it's going to divide out, right? The mass, whatever the units are of mass, don't matter. So if the units of mass are like, 1 box worth, then that does just fine for us. It doesn't matter. So I'm just going to count up how many boxes each one of these is. And then I'm going to remember in my final answer, I just counted everything as 1 on my graph here, but I think each one of these is actually 5 centimeters. So I'll just have to adjust that at the end, right? And remember to scale it up. So, or maybe I'll just do it right now. So part A, my x-coordinate, I'm doing it in units of boxes. So my x-coordinate is 5 centimeters times, and then I'll do this whole thing. Just putting that there so I don't forget to do that. Now I've got 3 pieces. I'll go from the bottom up. My bottom piece has an x-coordinate of 0. And there's 8 boxes there. If you're wondering to yourself, okay, fine, I get this whole thing. Why do you keep writing down the 0 things when you know that's going to cancel out? It just gives it a nice structure to be able to see what's going on, especially when you have like the 2 different ones. So I don't know. I like to do that. How about the x-coordinate of this one? The x-coordinate of this one is -1 times, that also has 8 boxes worth of mass, plus the x-coordinate of this one is 1, and that has 6. And the total number of boxes, 8 plus 8 plus 6, is 22. Okay, so what do we have here for our x-coordinate? Probably we're expecting something that's like, I would say like between 0 and -5 centimeters, if that's -5 there. It looks like I have a little bit more on that side. So let's see. I have -8 plus 6 is -2, yeah. -2 divided by 22 times 5 is -0.45. And that's in centimeters. So not just half a centimeter over there. So you could see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many boxes are on each side there? Let me just check. Just intuitively, that seems like our answer is a little bit small. Nope, that's right. Just wanted to double check there. Okay, so same thing with the y-coordinate. We're counting just boxes here, so I got to scale it up by that 5 centimeters for each one. And this is why I like to write in the zeros, because all of the times the masses, like the times 8 times 8 times 6, I should see a nice parallel construction of this expression here. What's the y-coordinate of this bottom one? It's -3. Y-coordinate of this one is 0. Y-coordinate of this one is 2.5. Okay, so -24 plus 15 is -9 over 22. 5 is -2.05 or 2.0, depending on how many sig figs you're keeping track of. And double check. That's good. That's how you do center of mass with a system of particles. And these aren't particles, but they can be reduced to particles because they're nice and symmetric-like.